Hello everyone, welcome to this presentation. My name is Surush and today I want to demonstrate our framework entitled Community Prediction in Text Streaming Social Networks. Community detection is a well-studied topic in social information retrieval, and we went one step further and create a framework to predict emerging communities in future. Our framework can be used in multiple user-specific or community-specific applications such as news recommendations or marketing campaigns. The method of this framework was previously proposed in a paper which is published in ECIR 2020 by one of the contributors of this framework. In this video, I'm going to show you a quick review on the README or code structure. Then I'll install the framework and show how it's going to work. To demonstrate our framework, we use the Twitter dataset or use the Twitter as the text streaming social network. Let's start with a brief explanation of our framework with these two images, the workflow and the layers. Let's start with the workflow. This is the main flow that we divided it into 3 steps. Suppose that users U1, U2, and U3 tweeted in 3 consecutive days, T1, T2, and T3. Topics are extracted from these tweets, and we show them in 2 colors, orange and yellow. That I call them Z1 and Z2 from now on. So the user U3 tweeted about topic Z1 in T1, and the topics Z1 and Z2 in T2 and T3. At the next step, users' graphs are generated based on the topic preferences similarities among all of the users separately for each time interval. In T1, user U1 and U3 are tweeted about Z1, and U2 tweeted about Z2. So in the corresponding graph, U1 and U3 are connected, and just these 2 nodes are connected in this graph. And we build the G1, G2, and G3 like this, separately and independently. And at the next step, which is a stand for temporally embedding G1 to G3 into the latent space to capture the user similarities over time. So each matrix is built based on the current and previous user graphs. Finally, we use the last embedding, which is V3, to predict G4 using some graph clustering methods called named Louvain for the future community prediction. And the next image is about our layers of this framework. As you can see in this figure, our framework consists of 6 layers. Data collection, data aggregation, and pre-processing are done in this layer, DAL, the data access layer. Processed data then fed to the topic modeling layer as well as the user modeling layer. But in the topic modeling layer, we use the LDA to extract the topics from the whole corpus and from each document for each user in each time interval. Then in the next layer, the UML users graphs are generated based on the topical similarities among the users. And this layer, GEL, embeds these graphs temporally. So the changes in users' preferences over time, these changes over time are considered. And the last embedded matrix has the whole information about the user's topical preferences from the first day that we collect the data. And we use the last embedded matrix to predict the future emerging communities in this layer, community prediction layer. And in each layer, we use some external libraries that I mentioned them in here. And finally, the application layer, the news article recommendation, is the application that we want to analyze our model, but by tracking the performance of this application.